Chapter 9, Exercise Set, Problem 4. This is an optional problem. It's not for everybody. But let's work on it anyway. A CNN Money article, College Cost Rights, published in October 29, 2008, reports the total annual income averages $34,132 for private colleges and $14,333 for public colleges. In an effort to compare those same costs in New York State, a sample of 26 junior students were randomly selected statewide from private colleges and 28 from public colleges. The sample means were 34,020 for private colleges and 14,045 for public colleges. A little bit old data, but it came from the textbook, which is relatively old, copied from even older textbook. Anyway, let's begin. Suppose that the total annual costs for private colleges in New York State are normally distributed. Estimate 98% confidence interval for the mean annual cost of the private colleges if the sample standard deviation was 2,150. Now this is a little easier problem because the problem explicitly said this was sample standard deviation. It's not sigma, it's S. So population standard deviation is not given, so it's unknown. Sample standard deviation is known, and we are talking about how many students here. For private colleges, we're talking about 26 students, small sample size, and finally, suppose that the original distribution is normal. So we have all three criteria for t-table. So let's go over. Whether it's z or t, well, it's a t-curve problem. Normally distributed, criteria number 1, and we only have sample standard deviation, not the population standard deviation. And finally, small sample size, just 26. All right, here's the picture. The observed mean was 34,020. Okay, there you go. That's the center. And we have 98% here. And then the other 2% must be shared. 1% here to the left and 1% here to the right. So let's find one of them and then find out the other through the symmetry. And let's see. This is going to be t-table problem, so let's go over to find the right-hand side endpoint here. But before that, I'll have to find out the degree of freedom. What's the degree of freedom? There are 26 students there, so 26 minus 1. So degree of freedom is 25. And then if you use my formula number 1, n minus center over SC is equal to appropriate t-score, I have my equation x minus 34,020 over the sample standard deviation over square root of n is equal to t-score. Yeah, that's about it. Solve that equation and I'm gonna be done. Okay, so here is the t-table, all right, and you're looking for 1%, so look at this column here, and let's go to the degree of freedom of 25, and we have 2.485. That's how you get 2.485. Solving this equation, you're going to get the x value. First, flip the denominator, standard error to the other side. And second, flip the center to the other side, and we have this. 34,020 plus the t-score times the standard error, and you get this value. That is your right-hand side endpoint here. How about the left-hand side? all we have to do is to use the symmetry. Change this plus to minus and run your computation. And this is your left-hand side endpoint here, right over there. Consequently, we get this confidence interval, 32,970 to 35,070, approximately speaking. And then here is the final picture. Okay, that wasn't too bad. It was just t-variable problem. I mean t-curve problem. Now, how about this one? Suppose that the total annual cost for public colleges in New York State are normally distributed with a standard deviation of 1,510 and find 98% confidence interval for mean annual cost for public colleges. A tricky problem. We have 1,510 as the standard deviation, but which is it? Is it the sample standard deviation or the population standard deviation? It's arguable, I know, but deciphering this problem, it's this population standard deviation given. You see? Because this came from the same sentence as the description of the population. The population is normally distributed with the standard deviation. It did not specifically say population standard deviation here, right here, which would make the problem, which would have made this problem a little bit easier, but the textbook author didn't do that. By doing that, made this problem harder. But if you look at this problem, I mean, if you read carefully, we're talking about the distribution of the population, and in the same sentence, we're talking about the standard deviation. So this is sigma, population standard deviation. So despite only 28 small sample size, we have to use the z-curve. Tricky, isn't it? So this is a z-curve problem. We know the sigma value. Okay, so we have this initial picture, 98% confidence interval, okay, and then 1% here, 1% there. This is z-curve, so I'd much rather work with the left-hand side endpoint. Okay, we are looking for 1%. All right, let's go to the z-curve and then find out 1% there. All right, 1%. Where is 1% here? Okay, here it is. Negative 2.33 or negative 2.32. So real z-score must be somewhere in the middle, negative 2.325, negative 2.325, and well, that's what it is. As a matter of fact, I used technology and got real correct value. So negative 2.32635. So it's even better than negative 2.325. Anyway, that's your z-score. So you get n minus center over SE is equal to z-score. And flip this standard error denominator to the other side, and then you get this expression. Flip over the center to the other side as well, then we have the little computation here. 14,045 minus z-score times SE, you're going to get this value, 13.381, and that's the left-hand side endpoint. How do you find out the right-hand side endpoint of this interval? Use the symmetry. Change this minus to plus, and that's about it. You get 14,708, approximately speaking. And finally, here's the conclusion with full visualization. So the 98% confidence interval is 13,380 to 14,710 respectively. And then here is the visualization. 98% in the middle and then left-hand side endpoint and the right-hand side endpoint.